We want the bullet to hit this target, but this target is 10 meters away. Now I use a hammer to hit the slug. Let's see what happens. The warhead flew forward in a straight line. Step it up and do it again. It could have spun out like this. Roll and hit the target. Now we put the slug in the barrel, then hit the slug with a hammer. The slugs traveled steadily down the barrel in a straight line, and it's spinning to hit the target. It's just a theoretical experiment. Realistically, we can't use a hammer to propel a slug. So let's try it with a little dynamite. Explosion generates high-pressure gas in the barrel. The bullet comes out of the barrel fast and hits the target, but it's still a pain in the ass. You have to release the warhead every time. Fill it with explosives. The steps are cumbersome. Inefficiency. So the next step is to improve. Shell casings have been added. Then we load the shells with explosives and design the primer. Detonated on impact from the outside. This makes shooting and loading efficient, but it's still not enough to hit it with a hammer. Also need a set of triggers to replace the hammer. Start by designing a hammer at the back of the firing pin. The hammer attaches to the spring at the bottom of the stock. This way, when the hammer is triggered, compression spring force, release the hammer again. You'll be able to complete a crash. Next, we merge the firing pin section with the barrel bushing. When pulling the barrel bushing, the firing pin partially pushes the hammer backward to build up force. Barrel sleeve front fixing. Nearby springs are connected to the base plate. Automatic reset after completing the pull of the bolt. Fixed required after hammer buildup. Ready and waiting to be inspired. Next, a set of mechanical connections is needed to get there. Here a component is used to hold the potential energy of the hammer. By special shape design, holds the hammer in the ideal position. We'll connect it to the trigger again, so that when we pull the trigger, you can release the hammer when. This part of the hammer does not automatically reset itself. It is also necessary to include a spring plate to secure the reset. At this point, the main design of the pistol is complete. The next step is to think about feeding the pistol. We designed the magazines. The feed is removed by sliding the bullet. First firing requires a single holster pull, simultaneous hammer buildup and projectile insertion. For a smoother bullet push into the barrel, we'll attach the barrel to the bottom handle, designed to tilt in small increments. Each pull of the holster tilts the barrel downward slightly. This way, the bullet can enter the barrel more smoothly. At this point, pulling the trigger releases the hammer to hit the firing pin to complete the activation. But it's going to explode and burn. Push the warhead to release kinetic energy. In the meantime, the recoil of the exploding bullet pushes the holster backward, automatically ejects and pushes shells into the barrel. The perfect pistol was designed. Waiting also misses a key point. A bullet explodes in a flash. Fast enough that when the recoil pushes the holster to the limit position, our fingers are still on the trigger too late to release it. At this point, the part is not yet against the hammer. It automatically hits the firing pin as the barrel resets. It's like pulling the trigger once and firing a round. To prevent this from happening, we also need to design an isolation component. The isolation part can only drive the top hammer part when the trigger is pulled, without affecting the reset of the top hammer parts. This allows the hammer jacking component to automatically jack the hammer every time, and the next time you pull the trigger, it releases the hammer. An automatic pistol was perfectly designed. Did you learn?